The simulator visualizes the spatial distribution and temporal oscillation of harmonic sound pressure fields confined within a rigid, boundary-aligned parabolic enclosure. Under the enclosure eigenmodes configuration, it renders steady-state, two-dimensional standing wave patterns using a fluid color-coded gradient, mapping positive maximum pressure, compressions, in red and negative minimum pressure, rarefactions, in blue, to demonstrate how alternating regions swap phases over time while leaving zero-amplitude acoustic nodes isolated as stationary, stable, dead zones. When toggled to wave focusing mode, the simulation shifts to dynamic propagation and geometric reflection physics, illustrating either an omnidirectional point source at the exact geometric focus producing spherical wavefronts that flatten into parallel plane waves upon wall reflection, or an incoming planar sound beam converging to concentrate its acoustic energy into a highly reinforced focal point. Finally, the system features an interactive crosshair probe linked to a live virtual microphone oscilloscope canvas, visualizing the continuous time series waveform, amplitude variations, and localized phase signatures at any specific coordinate point sampled within the chamber.